Hello friends, so we start with Panda series. In series we will create series. So first of all I am creating a series S with informatic practices. I am creating a series S with informatic practices. You can see here index is 0 and it is informatic practices. Suppose I want to repeat it again and again. So I have done you can see here again I have written S1 PD series informatic practices. I have mentioned index values here, that is 1, 2, 3, 4, 5. That means it will be repeated 5 times. You can see here index value, as I have mentioned, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. You can do like this. That means you can repeat as many times as you want. In next example, instead of a string value I have taken integer value, that is 14, and that will also be repeated as many times as I want. I have given index 5. This is your choice. You can mention. You can see the output. 1, 2, 3 is the index, 14 is the value. So this is the way through which you can create a series with constant values, repeating as many times as you want. You can give index as you want. Now the next example, I have taken value 10. In series I have taken value 10, and index, for index value I have taken a for loop. For loop A, for A in computer, that means it will be repeated 1, 2, 3, 4, 5, 6, 7, 8 times. The character which computer word is having, it will be repeated this much time. You can see here. This is the index value and it is repeated as you have mentioned number of characters here. So in next example, I have mentioned a list L1 having this and L2 having this values. So I will make a series with the help of list pd.series L1. That means these are the elements of my series. L2, this is L2, this is the index value. I am mentioning here index is equal to L2. That means index will be 0, 1, 2 like this. Let me run. You can see these are the index value and you have Sunday, Monday, lunch. So this way you can create a list. Now NaN. NaN means that you haven't defined any value. So if I have to give NaN, then I will mention it like this: np.nan, np.nan, like this, np.nan. So in this place you can see the output. NaN is not a number. That means I haven't given any number. So I have mentioned NaN. So like this you can give. If you don't want to give any number, you can write like this: np.nan. That means not a number. Now in my next example, I have created from dictionary. This is your dictionary, this is your value, and this is your key. So you have created a dictionary. This is your dictionary, and through dictionary you have created series pt.series. Then you have print that dictionary series, print s6. S6 is the series. Then you have given a name, weekday. Weekday is the name of this series. And then you have given the index name, day name. That means index name you have mentioned, day name. Let us see. So you can see here, this is your series, Monday, Tuesday, Wednesday. You have mentioned a series through dictionary. Then you have mentioned the name, weekday. You can see here, weekday. Weekday is the name of the series. Weekday is the name of series. Then index name is day name. Here you can see day name. At index it is day name. So this is how you can create a series with the help of dictionary. Now mathematical functions. As you can see, and A1 is equal to NP dot A range 11, 21. That means in A1 there will be 11 to 20 values. S7 is a series PD dot series A1 into 2. That means it will take 11 into 2, then 12 into 2, and index A1. That means 11, 12, 13 like this till 20. You can see 11 is your index till 20. Through this A range function you have defined 11 to 20. Then you are saying A1 into 2. That means 11 into 2, 12 into 2, 13 into 2. Like this you have. If you want to change this value, you can do it like plus, minus, multiply, whatever you want. Suppose I say plus 2. You can see 11 plus 2, 12 plus 2, 13 plus 2, 14 plus 2, like this. Now, this is your series, and then this is your index value. You are given A, B, C, D, E, F, G, H, like this. Now first of all I'll show you this series. So you can see A, B, C, D, E, F, G, H. This is your series. Now if I print just index value, if I want to print just index value, I will use series name dot index. So it will be just index. You can see index A, B, C, D, E, F, G, H, only index. If I want to print just values, I will give just S8 dot values. You can see just values. If I want to know its data type, I will say D type, series name and D type. You can see int. Suppose I mention here in decimal. You can see float. Now I want to check the shape. Save and I will run. So you can see 8. 1, 2, 3, 4, 5, 6, 7, 8. Now I want to check how many bytes. How many bytes? 64. It returns. It takes 64 bytes. Number of bytes in this data. In this data has 64 bytes memory. Now NDIM function returns the number of dimension. This is single row. See 1. Then size. Size. Number of elements in this. Again 8. Number of elements 8. Then item size. You can see here. Item size is 8. Number of element is also 8. And total it is consuming 64. One element is taking 8 bytes and there are total 8 number of elements. So 8 into 8 is 64 bytes. So overall n bytes means how many bytes it will have. So this is about item size and n byte. Has NAS is very important function. See here. False, because it is not having not a number, that is n. Suppose I write here np dot na. You can see it is true. That means if it will have any na, not a number value, then it will give true, otherwise it will give false. It's 9. I am checking whether my series is empty or not. That is S8. S8 series is this one. Empty function is checking whether this is empty or not. False. This series is not empty. Suppose in place of S8 I write here S9, and S9 I have created an empty series. You can see true because S9 is an empty series. Now, head and tail function. First I'll show you tail function. First of all, I'll also print your series. This I'm printing your series, and then I am using tail function. S8 tail function. You can see this is your series, and tail function will take last 5 values. 1, 2, 3, 4, 5. tail function by default will take last 5 elements and head function will take first 5. You can say this is your series and first 5 element is has taken. But if you want to define how many elements you have to take, you can define. Suppose I say in S8 had 6, it will take first 6 elements. If I say 2, it will take first 2 elements. You can see. Similarly, from tail it will take last. I have written 7, it will take last 7 elements. If I want to change, I can change. You can see last 7 elements. If I say 4, it has taken last 4 elements. So this was about head and tail function. Now here plus minus and this function. Suppose this is my S9 series and this is my S10 series, and this I have mentioned index, and this by default this is the index. So it's up to you. If you don't want to mention index, that is your choice. It's hardly matter. Now here I am saying S1 plus S10, that means 2 plus 1, 4 plus 3, 6 plus 5, 8 plus 7, 10 plus 9. This is your 2 plus 1, 3, 4 plus 3, 7, 6 plus 5, 11, 8 plus 7, 15, 10 plus 9, 19. Because here it is, I have written print S9, so that why it is printing X 2, 4, 6, 8, 10, S9 series. So I'll show you again. Maybe you will be confused because that at the time that was not as a commit. So plus is this. Suppose I say minus. Okay, it will be more clear if I display it here like this. Print S9, print S10. Might be maybe more clear to you. You can see this is your S9 series, this is your S10, and this you have add. Now suppose I say multiply. So you can see now it is multiplication. So like this you can do. If you want to do such calculation on single series, you can also perform it like this. Suppose I delete this series S10. Now suppose I am saying S9, print S9 plus 2. That means it will add 2 value to all the elements. You can see 2, 4, 6, 8, 10, 12. If I say repeat here 10. You can see. So now this is my boolean operations, true and false. I want to check S9 is greater than equal to 5. If it will be true, it will return true, otherwise it will return false. You can see here. First two value is not greater than 5, so false. 4 is also false, then these are true. So if you want to change this, suppose I say now, you can see. Okay, so you can give this kind of operation also. Suppose after this, if I want to get the values S9, so I will show you. You can see here, this is series. Now it is saying S9 is greater than 5, sorry, less than 5. This is a little bit confusing. I'll do the same here so that you are not confused. Now you see. S is less than equal to 5. So this is true. This has been printed. This is also true. This has been printed. False are not printed because I have written to print here. Suppose I change here value. Suppose I say 4 less than equal to 4. By this it will just give true and false. By this, when you write S9 here, this will give values which is true. See here, and here is equal to also. Less than is equal to 4. That means this 4 will be true because is equal to is there. So you can see it is less than equal to 4. That means for 2 it is true, 2 is less than 4, and 4 is equal to 4. These 2 are true and rest the false. Let me give us greater than, equal to, greater than will also take 4 because is equal to is still there. You can see. Because is equal to is still there, so 4 will come. This is your series. This for print S9. This a series is printed as it is. This, according to this print statement, it is mentioned false or true, and according to this statement, only true values are given. So this is all for today.